Sorry. And although we tried really hard to beat this very simple algorithm with more sophisticated heuristics, but we were not able to do it. So if you have any good ideas, I'm really happy to discuss. Thank you.
I'm Brian, and this is our work computing optimal equilibrium mechanisms by learning in general some extensive form games, which is joint work with this very long list of authors that I don't have time to read out. I'm on the job market this year, so yeah. Anyway, so basically, our work covers a wide variety of different cases, of different applications, where we can think of correlated equilibrium, we can think of communication equilibrium, generalized forms of mechanism design, information design over multi-step settings. And the thing that's common between all of these settings, the thing that our work is using, is that a solution in any of these notions is a strategy for the mediator or principal or whatever you want to call them, communication device, such that holding this strategy fixed, the direct profile, that is report information honestly and follow all recommendations, is an equilibrium for the players. So what we do here is we basically try to solve this sort of problem by using Lagrangians. And we look at two different Lagrangians, both of which have sort of been studied in special cases by other people, including Paul. And basically, we want to introduce this other Lagrangian at the bottom because it has the nice property that this Lagrangian has results in a zero-sum game whose utilities are bounded by some absolute constant. So the utilities do not depend on this Lagrange multiplier. So this leads to much better properties in practice. This leads, for example, you can run multi-agent RL without worrying about the fact that your rewards might blow up with respect to with the Lagrange multiplier. So in practice, this tends to lead to better results, and we believe at least on the left we're able to prove that that mechanism is the optimal one. On the right, we ran this with deep learning, so we don't actually know. But assuming our deep learning is reasonably good, then you can conclude that that mechanism would also be optimal. So that's all I have.